Okay. Good afternoon, everyone. My name's Brian Denvir. I work on energy markets and policy within Google data centers. My domain is very much outside the boundary of the data center. So OCP is new territory for me, but I'm going to speak a bit today about carbon-free energy, and more specifically about carbon-free electricity. So this presentation is very much about electricity supply to the data center, speaking about Scope 2 emissions and how we can decarbonize those. And really what I want to explain is how data centers can operate entirely or close to entirely on carbon-free electricity 24 hours a day, 7 days a week. So I'm going to explain what it is. I'm going to explain why some operators like Google, like Microsoft, like Iron Mountain are transitioning towards this 24/7 carbon-free energy framework for their electricity procurement. I'm going to explain how data center operators can get started on this journey, and a bit about collaborative data center industry initiatives working on this. But I want to start with renewable energy procurement. So over the last decade, data center operators have increased their procurement of renewable energy. And here I'm talking about direct purchases of renewable energy from wind farms and solar farms, long-term contracts like power purchase agreements, which help those projects to get developed. And Google, something that's driven this, one of the factors that's driven this is companies setting goals to be 100% renewable, to achieve 100% renewable matching. Google is one company that did this. In 2012, we set this goal. And this chart on the left shows, the green shows the volumes of renewable energy that we procured each year. So, and then stacks that up against our global annual electricity demand across all of our data center portfolio and our offices. And as you can see, in 2017, for the first time, we reached 100% renewable matching, which means Google used 8 terawatt hours of electricity in that year, and we bought over 8 terawatt hours of renewable electricity somewhere in the world at some time. Not necessarily in the same markets where we're operating our data centers, but that's what a 100% renewable match means, and we've maintained that since 2017 as our load has grown. Many other data center operators have set these 100% renewable targets, and as you can see, data centers are really leading the way and have been responsible for a huge amount of deployment of renewables. So in Europe, data centers have delivered around 9 gigawatts of power purchase agreements of projects. So really, data centers are at the forefront of this and have really helped to deploy new additional renewables to the grid. But if we're talking about trying to get a data center to operate on renewable energy, then 100% renewable energy doesn't solve that problem. And I can illustrate this with this graph, this schematic. The black line here is a sort of an idealized load profile for Google's data center in Iowa. So if we assume it's sort of roughly flat, and the green line show the wind power that we've procured directly from wind farms within that same region in the US. And we all know that wind and solar power are intermittent, so we have periods where we have an abundance of renewable energy, but then periods where we're not buying any or there's nothing being supplied, and there we're really reliant on the grid to supply our electricity. And the grid in Iowa is still very much made up of fossil resources. So we can't really say that we're operating cleanly at Scope 2 level, which is why we're kind of moving beyond 100% renewable in Google and setting a new goal for 24/7 carbon-free. So our goal is to operate on 24/7 carbon-free energy everywhere, at every data center, in every hour of every day by 2030. And the big change here is moving from a kind of a global and annual matching mindset to an hourly and local matching mindset. So 24/7 carbon-free energy means you're consuming electricity, and we're matching the supply of electricity on the same grids with carbon-free electricity every hour of every day. This animation on the right kind of shows this. This is what we call a carbon heat map for a data center. It shows the level of carbon-free energy supplied to the data center from that grid in every hour of the year, with the dark gray and black being more fossil fuel heavy and the solid green being 100% carbon free. And our goal is to take this map and turn it solid green at every facility by 2030. We've published a paper on how we intend to do this and explain a bit about the principles that underlie 24/7 carbon-free. But I mentioned some of them. The first two are really the key ones. Time-based matching, moving from an annual match, purchasing 8 terawatt-hours of electricity renewable somewhere in the world at some time, to trying to make our load match the renewables that we supply on the grid in every hour. Local procurement, so there we're talking about the same regional grid. So in the case of Europe, we're talking about the same country or the same bidding zone. We're moving to a more technology-inclusive approach beyond solar and wind to also include other renewable technologies like geothermal, to include battery storage, to include demand flexibility, but also potentially in the future to include advanced nuclear and the full portfolio of carbon-free technologies. Additionality is key. We want to try and add new additional technologies to the grid and new projects. And with a 24/7 carbon-free framework, this is the really key piece, that the ultimate goal is to decarbonize the grid. It's about aligning our clean energy procurement strategy with the decarbonization needs of that specific grid. So we look at the technologies that are on the grid, and we think, how can we maximize the supply of carbon-free energy? If there's a lot of wind already in the grid, that might steer us more towards solar or complementary technologies. And this is the ultimate goal. It's about making these clean energy procurement strategies reinforce the decarbonization of the grid rather than just buying wind and solar where it's cheapest. Why would we do this? There's lots of benefits, these benefits, these were identified in some recent analysis from the International Energy Agency, from the Technical University of Berlin, and from Princeton University, who conducted some modeling looking at the impact of not just data centers, large energy consumers adopting a 24/7 carbon-free framework versus a 100% renewable framework. And what that modeling has shown is it delivers greater emission reductions, both for the grid and for the operator, the data center operator, faster retirement of fossil fuel capacity from the grid. It can help accelerate innovation of new technologies. This framework forces us to look at other technologies beyond wind and solar. So we've entered into an offtake agreement with a geothermal project in Nevada, for instance, to make sure we can fill in the gaps in supply. Importantly, it also helps reduce the financial risks of procurement. So with the energy crisis, there's been a lot of talk recently about the benefits of PPAs in providing some sort of price hedging, some sort of predictability in electricity price. PPAs can do that, but they can only do that when the projects are generating. When they're not generating, you're still exposed to spot prices. 24/7 agreements can help fill in those gaps and minimize that price risk. And then finally, it also brings the operator, makes them a force for change with policy. We have an incentive to see policy change that helps us deliver this and helps the grids that we're operating on decarbonize faster. How are we doing it? I only have 15 minutes, so I can't explain everything, but one thing that we're indexing heavily on is changing how we procure electricity, changing the procurement model. So I can illustrate this with an example of a deal we did with AES, an energy utility in the US, in Virginia. Instead of just going to the energy utility and asking for a regular electricity supply contract, or instead of just asking for a couple of PPAs, we asked them to construct a portfolio of technologies, of wind and solar, hydro, and battery storage projects that can give us a guaranteed level, minimum level on average of 90% carbon-free electricity supply to the data center. And we end up paying some small premium for that, but our hope is that these sort of energy supply contracts will become mainstream, will become an offering that every energy utility can offer to a data center operator of any size, but also smaller consumers, smaller businesses, so that they can make sure that they're actually operating on carbon-free electricity. This is a growing global movement, the 24/7 carbon-free energy movement. If you're interested, there is a United Nations coalition called the 24/7 Carbon-Free Energy Compact, which consists of energy buyers, but also energy suppliers, cities, states, and also solutions providers. And it's a knowledge-sharing network on how to get started in 24/7 carbon-free energy. There is also, closer to home in Europe, Eurelectric, the trade association for the electricity industry, has established this European 24/7 hub, whose goal is to accelerate the adoption of this 24/7 carbon-free approach. And here there's a lot of information, a lot of their training resources to help companies start out and start measuring their 24/7 progress and to ultimately set similar goals. Very briefly, I wanted to touch on the role that some of our kind of industry coalitions can have, specifically thinking about key performance indicators and the work that OCP and, in Europe at least, the Climate Neutral Data Center Pact are doing on key performance indicators. So when we talk about measuring how clean the electricity supply to a data center is, we currently have two main KPIs, renewable energy factor and carbon usage effectiveness. Both of these have some shortcomings. Renewable energy factor, for instance, does not consider where the generation is coming from or when it's generating, so it doesn't consider this matching. And carbon usage effectiveness doesn't factor in the impact of off-site power purchase agreements. You don't get credit for those. So within the Climate Neutral Data Center Pact, there are conversations about how can we move these KPIs forward, or how can we develop new key performance indicators that increase transparency and help incentivize much more impactful clean energy procurement approaches from data centers. Just wanted to share as well a few of the kind of key lessons that Google has learned from embarking on this 24/7 journey. The first one and the main one I'd like to leave you with is that it's about really changing your mindset and not necessarily setting a new goal. So Google has set this 24/7 goal. Microsoft have set a goal. Iron Mountain have set a goal. Some cities and the US public agencies have set goals. But not everyone has to set a goal. Not everyone is ready. Some businesses haven't done their first renewable PPA. But what we're looking to do is to encourage companies to start thinking about this matching approach and start measuring it. There are tools that you can start to measure the extent to which you're matching on an hourly basis without necessarily setting a 100% or an 80% goal. To deliver it, we're looking at, I mentioned new transaction structures, new ways of buying electricity. We're also looking at new technologies and looking at the policies that are needed to enable more companies to do this. And then the third point is it needs to be made easier for consumers. So the market is really responding. Energy suppliers are now beginning to offer these supply contracts. There are many service providers who are helping companies start measuring this with their existing renewable energy supply. So the market is responding, but we obviously need to simplify this. And then finally, the carbon-free energy manager supply agreement. So this is the example I gave of AES, the AES supply deal. We want energy utilities to supply this to companies. And my final call to action is for anyone who's interested to join a coalition that's working on 24/7 carbon-free energy. We have the Eurelectric 24/7 hub. There's the UN 24/7 Carbon-Free Energy Compact. And for those who are just getting started in renewable energy purchasing, the resource platform is the European Coalition of Energy Buyers and Suppliers working on PPAs, power purchase agreements. And it's a fantastic coalition and really a great way to get started. And also a call to join some of the data center industry initiatives working on how we measure clean energy supply, so the Climate Neutral Data Center Pact, but also within the Digital Europe Data Center Project. This is a question we're working on. That's everything from me. Any questions? Thanks.
Thanks, Brian. When you said about using the energy from the same region, what do you exactly mean with the same region? Where does it start, it ends? Does it also play a role to have co-located projects from energy and data center? And
yeah, it's a good question. So as much as possible, we're looking to source as close to the data center as we can, but we know that's not always possible. So with same region, what we're talking about is the same electricity market bidding zone. So in Europe, that approximates to countries, except in the Nordics, where you have some split bidding zones. so that we have some physical tie between where we're sourcing the energy from and where the operations are. Please.
Hi, Brian. I'm going to get myself into trouble here. But how do you say it's carbon free? Because in my book, no energy generation is carbon free. Everything has a carbon intensity. So is it something to do with the fact that you're exporting well, maybe you can explain how it can be carbon free.
Yeah, so it's the point I was making at the start that we're talking about scope 2 emissions as they're measured, so electricity emissions only. And of course, in the manufacturing of wind turbines, there are emissions in the supply chain. In any technology, energy generation is supply. But as it's measured under scope 2, we're talking about carbon free. So it's as close to carbon free as the operations can get, I think, without being on a grid that is completely carbon free.
Oh, I see. So you're not, I mean, if you look at things like electricity map and things like that, they say they give a measure of the carbon intensity of the electricity being generated at that point in time.
Yes.
And it's never zero.
Yes.
And that's because, even if it's renewable or, wind turbines, for example, wind turbines use sulfur hexafluoride. And that's a greenhouse gas. That's a greenhouse, and it has a carbon CO2 equivalent intensity.
Yeah.
That should be taken into consideration.
So we do actually use the electricity maps data for measuring this. And my understanding is that it's limited to the operational electricity emissions on electricity map. So they wouldn't take into account those kind of emissions. They are captured elsewhere in the scope accounting. But yeah, it's as close, I think, to carbon-free electricity supply as you can come.
Okay, I think we probably need some standardization on this. This is the problem, because we might not be talking about the same thing. But I don't think we should be ashamed of it. I mean, we're 19% carbon ourselves. So what's the big problem with carbon?
Yeah. Well,
We've got
no, I
other
mean,
problems,
ultimately
not
we
carbon,
do.
yeah.
It's a good point, because we need to get to zero emissions. We are net zero at the very least. But I think in the scope accounting, in the greenhouse gas protocol accounting, scope 2 wouldn't include those emissions, and that's kind of the framework we're looking at. But it is a good point. We need to decarbonize the source as well. Okay. Thank you. Thanks, everyone.